So in the last video, we saw that how functions can be thought of as machines. So you have an input in some function and it gives you an output. Let's call this y. Now depending on what type of function you have, you can have restrictions on x, and so these restrictions on x, okay, and if you have some restrictions, then you have only certain values of x which you can put into this function, and those values or the collection of those values is the domain. All values of x which the function can take, and it's very reasonable that depending on what type of function you have, your y can also have certain values, and the collection of such values is known as the range of this function. Alright, and that's what we'll be studying today, how to find range of some functions. Now let us consider a function, very simple one. Y is equal to root x, okay? So f of x is equal to root x. Now the thing with roots is you can't have something negative inside a root. Okay, I've already explained this. So x should be greater than equal to 0, and it can be any number you like. Okay, something greater than 0. So we can say domain of f is 0 till infinity. This means 0 can be included in our domain till infinity. And what is the range of our f? Well, the thing is, another important thing of roots is that this root of x will always give us a positive value. I've discussed in my previous video. And since it can't give a negative value, its range is also from 0 to infinity, 0 included. And you can easily see from the graph. Alright, so this is how it's a very rough sketch, but yes, so you can easily see that it is increasing. Okay, at 0 it is 0, then at x is equal to 1 it's 1, x is equal to 2 it's 1.4 approximately, and it goes on increasing. Now interesting thing is, we do have some kind of functions which kind of look like the root x, alright, but they gradually approach some value of y. So they look something like this. Okay, and let me call this value somewhere. Why not? Okay, so yeah. So no matter how large x you pick, it is always lesser than this value y0. And example is how capacitor charges. I have made some videos, you should check them out. So it's given by e to the power something. Now let us look at another example. So consider the function f of x is equal to x minus 3 upon x minus 5, and you want to find out the range and domain. So you can easily see what the domain is. Okay, domain of f is all the real numbers minus 5. Okay, the set of all real numbers, you remove 5. Not why? Because if you put 5 in f of x, it will take the form 2 by 0, which is not defined. We have discussed this logic earlier. Now what is the range of f of x? There is a simple way we can do this. We can call this y. Okay, so y equal to x minus 3 upon x minus 5, and then write y x as a function of y. Okay, you will see in a minute why that works. So how to do this? Well, just cross multiply. So you get xy minus 5y equal to x minus 3. Alright, from this you get x y minus 1 equal to 5y minus 3, and from this you get x is equal to 5y minus 3 upon y minus 1. So you get x as a function of y. And now you can put the restrictions, put your restrictions on y. Now what restriction do we have on this function? The denominator must not be 0, so y cannot be 0, and if y cannot be 0, the domain of this function, okay, is r minus 1, and the domain of this is the range of our original function. A set of values y can take these values, r minus 1. This is our domain, r minus 5, and this is our range. Let me draw the graph of this function. So this is how the graph of this function f of x versus x looks like. Now take a minute to understand this thing. See the domain. First of all, let's see where it is 0, okay, where f of x is 0. So f of x is 0 when x is equal to 3, easy to see. This point is 3, okay, and f of x can be any value, okay, but not 5. So if any weird thing happens, or two lines go in the opposite direction, one towards positive infinity, one towards negative infinity, that happens at 5. And yes, for other values f of x is very well behaved, let's call it. So as you can clearly see from the graph, this value, okay, is 5. So if you draw dotted lines, you can see at f of 5, okay, doesn't really give us any value. And let us have a look at the other values of x. So the other values, you have someone at this point you have this value, at this point you have this value, but other values f of x is well behaved. And let us now focus on the range. Okay, write this down. Range of f is r minus 1. And if you look at 1, but this one is on the y-axis, okay, because you're talking about the range, a set of values that y can take. So this is obviously on the y. I'm talking about the y-axis. So at y equal to 1, you can see it doesn't really approach a value. If you draw lines parallel to the x-axis, you see y equal to 1 doesn't give us any value. 1 is going towards minus infinity on the x-axis, and 1 is going towards positive infinity in the positive x-axis. Now let us try another function. Now consider the function f of x, okay, x square minus 16 upon x minus 4. And now say you want to find the domain and the range. So the domain is easy, okay, I'm just writing it straight away. Main f, anything. Well, let's have minus 4, right? That's what our intuition will tell you. But that's wrong again. Because you can factorize the numerator x plus 4 x minus 4 upon x minus 4. Cancel them out, you get x plus 4. Alright, so the domain is not r minus 4. I already did a previous similar example in my previous video. And now if this is our function f x plus 4, you don't have any restrictions as such, right? X can take any value and f of x will give you any value. So the domain and range of this function are all real numbers. Domain is r and the range is also r. If you want to confirm this, okay, you can plot this function, right? If you plot this function, not even x plus 4, you plot x square minus 16 upon x minus 4, you will get a graph like this, okay? This is y, this is x, something like this. Okay, it's a straight line. And what are the values? Well, at x is equal to 0, it is 4. Oops. 4. And it is 0 at minus 4. And this is exactly the graph of x plus 4. Okay, because this function is x plus 4. So in functions like this, when you can factor out and cancel stuff, the domain, and you find out something like this, okay, x plus 4. So the domain is all real numbers. Okay, for every value of x you have one value of y, and the range is also all minus infinity to plus infinity, or all real numbers. Okay, y, if you extend this graph, okay, so then y will go more and more negative. If you extend it towards the positive x-axis, y will go on increasingly positive. So with that given, let us try. I'll give you a question, and so consider f of x to be root 64 minus x square. Okay, and this question is for you. Find the range and domain of this function. Okay, do answer in the comment section. A hint that that you might want, that the thing is root can't take negative inputs, so 64 minus x square should be greater than equal to 0, and this function as a whole will always give you positive values. Now we can have some functions in which you can give any x as an input, but still you have very fixed value for y. A good example is our trigonometric functions. Okay, sine and cosine. This is what sine of x looks like. Okay, x is in radians, and this is what cosine of x looks like. So let us talk about sine of x. You can see it oscillates between two values of y. Okay, this one and roughly this one. Now what are these two values? And if you remember the basic idea of sine, this is a unit circle. This has a radius 1 unit, and it makes an angle x. So sine is nothing but the y-th component, or how much this point is above this axis. So obviously the maximum height it can achieve, this point can achieve, is this one, and this height is equal to the radius, which is 1. So the maximum value of sine is 1. And what is the minimum value? Well, the minimum, the lowest point is this one, where it is 1 unit below this axis. Alright, so if it's 1 unit below, then its value is minus 1. So this is minus 1. And if you remember your tables from trigonometry, you know sine of 0 is 0, right? When x is 0, you get a line like this. Okay, so it has no vertical component. Sine is 0. Now as you move this point towards pi by 2 radians, so you see the y part is increasing, and its maximum at pi by 2. This value is pi by 2. This is 0 at pi again. This is when it's negative. Okay, so it's 3 pi by 2, and then you can move this your point anti-clockwise also. Then you start getting negative values for your x, right? And this is minus pi by 2. This will be minus pi. This will be minus 3 pi by 2. So you see, it's a wave, and these functions sine is extremely useful when we deal with waves in physics. Okay, any sort of wave you can decompose it into sines and cosines. It's a very interesting theorem of mathematics. So next up is cosine. Okay, it's a very rough graph, but still, again, it seems to oscillate between two values. What are the two values? Yeah, I have guessed it correctly. It's 1 and -1. Again, you can see it from our basic understanding. Cos is nothing but the base. Okay, this part. So when this point is a right, x is 0, this point is right on this axis. Okay, this has a maximum value of cos x, which is 1. So at 0, this is 1. And as you move the point clockwise, the base component, the horizontal component along this axis is decreasing. Okay, so you mark this one, and this is your cos. Okay, and if you are right at pi by 2, your cos is 0. This point is pi by 2. And if you are at this point, okay, pi, x is equal to pi, then you are at distance 1 unit, but in the left, towards the left, in the left direction. So this will be -1. This pi. So cos pi is -1. You must have known this. And again, it's 0 at 3 pi by 2. This angle. Okay, and it again approaches 1 at 2 pi. Similarly, just like we did for sine, extended sine towards the negative values of x, we can similarly do it for the cosine. We can start measuring x in the clockwise direction. Okay, so this will be minus pi by 2. This will be minus pi. This will be minus 3 pi by 2. So we saw a lot in today's video. We saw how to take range of functions, and we saw examples where range is sort of restricted between two values. That's all for today. Thanks for watching.